Reverse engineering, day 21. Help me, I'm reverse engineering. McSkitty's alert dashboard lit up with an unusual alert. A file-sharing web application built by Glitch had triggered a security warning. Glitch had been working hard during this season's Sackmas of the Lost Scare with the Yule log exploit, but this new alert caused McSkitty to question his intentions. McSkitty began to investigate. It seemed the source of the alert came from a binary file that made its way to the web app's backend. It did not belong there and had some anomalous activity. The binary was compiled with .NET. The whole setup seemed quite unusual. And with Glitch working on the latest security updates, McSkitty was filled with suspicion. As McSkitty continued her investigation, Glitch rushed into her room. I swear I did not put it there. I was testing the fences, but I wouldn't go that far. McSkitty reassured him. This doesn't look like your work. Let's go to the bottom of this. Put on your decompiling hat, and let's see what we are dealing with. Learning objectives. Understanding the structure of a binary file. The difference between disassembly and decompiling. Familiarity with multi-stage binaries. Practically reversing a multi-stage binary. Connecting to the machine. Before moving forward, review the questions and the connection card. So we have a text box. Hopefully we can do Kali. Yeah, we have RDP. Is it /SSH? Yeah, I'm guessing RDP today because it's probably a Windows machine that we are just gonna run stuff on, right? But we will also use another machine. Split screen available assets and I don't know, Cyberroom. And you're supposed to be able to run it without VPN. So, yeah. Click on the green Start Machine button to start the machine. So, it will start it in 95. So let's actually minus it and hope that it works as it should. So we will get an IP address here soon. We'll just continue reading meanwhile. And we already know it's .NET decompilation, so let's just read on. Introduction to Reverse Engineering. Reverse engineering, RE, is a process of breaking something down to understand its function. In cybersecurity, reverse engineering is used to analyze how applications, binaries, function. This can be used to determine whether or not the application is malicious or if there is any secret bugs present. So I'm guessing this is, let's see, that wasn't a big increase in size. What happened to my computer? Oh, okay. For example, cybersecurity analysts reverse engineer malicious applications distributed by attackers to understand if there are any attributable indicators to associate the binary with an attacker, and any potential ways to defend against a malicious binary. A famous example of this is the WannaCry ransomware in May 2017. Security researcher Marcus Hutchins reverse engineered the ransomware application and discovered a specific function within the application where the malware wouldn't run if a particular domain were registered and available. So, Marcus then registered the domain, stopping the global WannaCry attack. This is just one of many famous cases of reverse engineering being used in cybersecurity defense. And I think actually he's the one who made the video. Yeah. So, Maybe you want to watch this one. Maybe I'll tell some stuff about that. Binaries. In computing, binaries are files compiled from source code. For example, you run a binary when launching an executable on your computer. At one point in time, this application would have been programmed in a programming language such as C#. It is then compiled, and the compiler translates the code into machine instructions. Binaries have specific structure depending on the operating system they are designed to run. For example, Windows binaries follow the portable executable P structure, whereas Linux binaries follow the executable and linkable format ELF. This is why, for example, you cannot run an exe on Mac OS. With that said, all binaries will contain at least a code section. This section contains instructions that the CPU will execute. A data section. This section contains information such as variables, resources, images, other data, etc. Import-export tables. These tables reference additional libraries used imported or exported by the binary. Binaries often rely on libraries to perform functions, for example, with the Windows API, to manipulate files. The binaries in today's task follow the PE structure. This structure will be explained throughout the task. Disassembly versus decompiling. When reverse engineering binaries, you will employ two primary techniques. This task section will introduce you to disassembly and decompiling, explaining the key differences and their pros and cons. Disassembling a binary shows the low-level machine instructions the binary will perform. You may know this as assembly. Because the output is translated machine instructions, you can see a detailed flow of how the binary will interact with the system at that stage. Tools such as IDA, Ghidra, GDB can do this. So, we've done this quite a lot recently, right? On stream. Look at all the buffer overflow stuff, right? So, decompiling, however, converts the binary into its high-level code, such as C++, C#, etc., making it easier to read. However, this translation can often lose information, such as variable names. This method of reverse engineering a binary is useful if you want to get a high-level understanding of the application's flow. So, well, it's not the same with .NET, but they will come to that, I'm sure. There are specific circumstances where you would choose one method over the other. For example, decompiling is sometimes a best guess based on the tooling you used and does not provide an actual full source code. A table outlining the differences between the two has been provided below. So, readability, requiring knowing assembly and low-level knowledge of computing concepts, requires familiarity with programming and logic. Level of output. The translated output is the exact instructions that the machine will perform. The translated output is often best guess. The output may not be accurate, and useful information such as variable function names, etc. will likely be lost. Difficulty. The difficulty can be considered higher as the machine instructions are translated into assembly. The machine instructions are translated into high-level language, which makes them easier to understand if you're familiar with the language the binary is written in. Usefulness. The entire behavior of the binary can be studied given enough time. Decompiling is a quick way to understand some of the logic of the binary. And why do we have to choose, right? Didn't we just see both? No, we didn't. So, multi-stage binaries. Recent trends in cybersecurity have seen the rise of attackers using what's known as multi-stage binaries in their campaigns, especially malware. These attacks involve using multiple binaries responsible for different actions rather than one performing the entire attack. Usually, an attack involving various binaries will look like the following. Stage 1, wrapper. The binary is usually a lightweight basic binary responsible for actions such as enumerating the operating system to see if the payload will work. Once certain conditions are verified, the binary will download a second, more malicious binary from the attacker's infrastructure. Stage 2, payload. The binary is the meat and bones of the attack. For example, in the event of ransomware, this payload will encrypt and exfiltrate the data. Sophisticated attackers may further split actions of the attack chain, e.g. lateral movement, into additional binaries. Using multiple stages helps evade detection and makes the analysis process more difficult. For example, a small, more harmless initial binary is likelier to evade detection via email filtering than a fully fledged binary that performs malicious actions such as encryption. Additionally, splitting these functions into multiple stages gives the attacker much more control, i.e. only downloading specific stages once conditions such as time have been met. The diagram below shows what an attack involving multiple stage binary may look like. Yeah, I have to drink some in my throat. We'll see if I can read all of this. It's actually from Lemon throat stuff. So, phishing email, compromised site, entry point, drops, doc, PDF, RTF. I'm assuming they mean there's a link. Execute, JS, PS, downloader, www, and then downloads and executes. So the first thing that's executed is the download, and then the malware itself. So you could really say 3 stages then, right? Or more. Jingle.net all the way. For today's task, you will be reverse engineering 2 .NET binaries using the decompiler ILSpy. You can follow the walkthrough below in reverse engineering using an example application named Demo.exe. Then you will reverse an application on your own at the end of this task. Before analyzing our target, we need to learn and find a way to identify the original binary file, modify it, use it as evidence. Also, it's good practice to have a big picture of the file we're dealing with so that we can choose the proper tools we'll need. Can't really do that in my mouth. So, let's start by navigating to the file location in the demo folder on the machine's desktop by right-clicking on the file named demo and clicking on properties. So let's start by actually connecting. So we continued reading and didn't actually connect. So yeah, it wanted to work at once. That's nice. So let's see what the password is. AOCRE123 exclamation mark. and administrator, but we need to set the IP address too. Fingers crossed now that it actually works, because yesterday we had to, or last time we had to use a split screen because it didn't work. Woo! Nice. So, I'm just scrolling down to where we were actually. Navigate to the file in the demo folder. Right click and do properties. So now we're at the same place they are. We can observe that the file is an exe. Well, I'm like, did they really hide the extension? They did. I don't get why anyone would do that. Application exe at least does. So, since it's a Windows file, we'll use PE Studio, a software designed to investigate potentially malicious files and extract information from them without execution. This will help us focus on the static analysis side of the investigation. Let's open PE Studio from the taskbar and click on File Open and select the demo exe located in C as shown below. So let's do PE Studio and let me go File Open. I'm assuming we could just click the Open too. And let's go to, yeah, we already know what the file is. It's in demo, right? So, I'm sorry that the size is so tiny. Oh, I'm sorry. Well, let's fix this. Let's fix it. So the last machine, we changed our scaling because we were looking for stuff in Event Viewer, and it wasn't nice to not see a lot of text. So now we want a bigger, better scale there, so we have a little bit bigger text. So let's hope we can see good enough with this. So I don't like extremely tiny text, it's not very nice. Hard to read on a phone especially, right? So, as shown below, PE Studio will display information about the file. So let's start enumerating some of the most important aspects we can get from it. Using the left panel, we can navigate through different sections that will share different types of information about the file. In the general information output displayed when opening the file, we can see that the hash of the file is a form of, let's see, where is it? Can you see it here? Oh, it's a big yellow, and it was top shelf at 256. The architecture type, in this case, x64, and they're probably 64-bit here. The file type and the signature of the language used to compile the executable, in this case .NET Framework. So you can see here, it's Microsoft.NET that uses a C# language. Well, I don't see anything about C#. Let's focus on some critical data we can obtain. First, we want to identify the file and provide evidence of its alteration. We need to take notes of the file's SHA-256 hash, as we mentioned above, as well as the hash of each section of the PE file. PE stands for Portable Executable, and is a format in which Windows executable are arranged. You can learn more about them here. And we have a link to Microsoft page about PE format. So I think I'm right in there. So also we had a link to PE Studio here. We can also click. Did we miss any other links? So, the free or the paid version. So, those sections, and we're in this document that I'm looking at. The different sections. Quickly scroll through this. Yeah, let's just click that link too. So we'll hop to the bit where they wanted section table. Yeah, it's kind of early in the file or in the document. So access raw data, point on raw data, point to locations, line numbers, number of locations with line numbers, characteristics. The section represents the memory space with different content and a Windows executable with a PE format. We can calculate the hash of these sections in order to identify the executable properly. We'll focus this time on two hashes. The one from the .text section, which is the section of the file containing the executable code. This section is often marked as read and executable, so it should not have any alterations when the file is being copied. You can observe them in the screenshot below. So, section.text MD5, so we have the MD5 there. Let's actually look a bit at what we can see here. So we can see we have the .NET here, 64-bit, console, and demo. And of course the Shelter6, 1, and MD5. And the first bytes of the file. 2. So then we can see this one. System.net URL. Try hack me connect. File entropy. Those again, the size. Data execution prevention depth on. Control flow guard CFG off. Address space layout randomization is LAR on. File subsystem so manifest name. My application.app version. So then we have the footprints that they went into and looked at the section in the file there. And we get an error on virus stuff. I don't know what the issue is in here, but I'm thinking maybe that's a pay thing. Oh, of course, this is a we don't have network thing. Yeah, this machine doesn't have internet. So we'd probably see stuff here if we were on a real machine, right? So another essential section we can use to obtain information about the binary is the indicator section. This section tells us about the potential indicators like URLs or other suspicious attributes on the binary. Screenshot above shows several strings on the file, like file names, URLs, and function names. This can be very important depending on the file's execution flow. Additionally, looking for artifacts such as IP addresses, URLs, and crypto wallets. And it can be a quick win for gathering some identifying intelligence. We'll learn about that in the next section. So why haven't I used this on Windows executables? I don't know. We'll have to add it to the notes. Now that we have information about the file we're investigating, let's try to understand what the executable is doing. We need to know its flow. If we try to read the file by opening it, we can't do it since it's in binary format. In the previous section, we learned that the file is compiled using the .NET framework used by the C# language. We can decompile the binary code into C# using the decomposition tool like ILSpy. This tool will decompile the code, providing us with readable information we can use to determine the flow of execution. Let's start by opening ILSpy from the taskbar and then click on File Open. And then navigate to C:\demo. And select the file. It'll take up to 30 seconds, not minutes, fortunately, to appear on screen. Yeah, so let's quickly just check through the rest here. So I guess that AMD61. There won't be a lot of information that is interesting here, or they would have told us, right? Maybe there's interesting information here. Libraries NA. .NET namespace flag. Just a few more strings. So there's also strings here. So let's actually read what it says. So download file. Yeah, we don't have to read it all. So let's decompile it. So ILSpy. This background. The mayor looks very nice, right? It's like got hoofs too. What is it really? It's like they're like animals. Maybe not. Maybe it's just a snowman or something. So 30 seconds to start. Kinda good they said that, or I would have clicked again, right? And we got 2 ones. Is that their dog? Or is the dog not in there? Is their dog actually a robotic dog? With antlers. It looks kinda like a dog face, right? With ears and everything, and then we have so we don't have demo. Right, we need to open it first. I'm like, yeah, right. So, let's open. There was probably an open icon, right? So desktop, demo, demo, and demo. So as we can see, as we can observe from above, the left panel contains the libraries used by the framework, and the actual decompiled code is in the section with the file name demo. Let's click on it and expand to see what it contains. So let's click the demo binary program. Yeah, I'm a bit tired. Let's just go on. So, yeah, you're already watching the screen, are you? Yeah. Oh, we click the main function, and it's decompiled for us. Hello THM demo binary, sleep 5000. String address, string text, path combine, environment get full of path, desktop, THM demo PNG using web client. New web client, right? Console right now, downloading file. To start process, use shall execute true. Image opened successfully. Catch exception. Never occurred. Like the image didn't exist, right? Bye bye living demo binary sleep 5000. So seems like an extremely simple program. I'm just curious what we see here. Yeah, so here we see the full thing. With just dot dot dot. We can expand it, right? So if we click demo binary, we don't see anything. We just see it on the program. That was expanded already. So MG references. So it uses stuff. Also using, we can expand there. As the screenshot above shows, as by can provide much information like metadata and references. However, the actual show is displayed on the bracket symbols. In this case, demo binary program mine, which is actually the main function of the executable. Now that we have access to the code running on the binary, let's analyze it. Yeah, I already read it, so the code above displays the main function of this code. We can observe the first, it prints the screen a message, hello. Uses sleep. Then it assigns a value to string2 variable. Address and text, the first one with the URL accessing PNG file, and the second one with the file name on the user's desktop, called THM demo. Then it will try to connect to the URL on the address variable and save the content to the file on the desktop using the web client class. And it will then execute and download the path assigned to the text variable using the process class and start method as just made. Hello. And they give us the code again. So process start. Process started. Finally, it prints the message. Bye bye. I'll wait for 5 seconds. Great, we now understand what the binary is doing. It will download a PNG to the user's desktop from the URL. Let's execute the file and see if it is true. Once the binary starts, wait for the text hello THM demo binary to appear, then press enter to download the file. And we're only executing the binary because we're in a sandbox environment. Execution of an unknown binary on a host machine is not recommended. So it's very unknown binary. It's not just a demo one. So let's open it. And of course we could just run it at the command prompt or something too. But let's just double click it. So demo, and it will open the command window. Hello THM demo binary. Downloading file downloaded, and we saw it appear. And then it opens it. So, and the window disappears. So we have a download image. After executing the file, we can observe that it was downloaded to the desktop and the message print to the screen as expected. Also, the downloaded file is executed and opened using the default app for PNG Paint. Excellent, we successfully reverse engineered the flow of the code. Now that we have some practice, join McSkitty and help investigate the alerts coming from the file where-will-app.exe. Put on your reverse engineering hat and help decipher the mystery behind the suspicious binary. To answer the question, we'll need to reverse application where-will-app.exe located to the administrator's desktop. So, it is us, that is the administrator. We're loading this administrator, so it's just here. So let's open the PStudio again. We have questions, of course, too, that we're supposed to fill out. So let's actually look at these first. What function name? What is a function name that downloads and executes files in the where-will-app.exe? Once you execute the where-will-app.exe, it downloads another binary to the downloads folder. What domain name is the one from the file is downloaded after running where-will-app? And then the stage 2 binary executed automatically, and it creates a zip file compromising the victim's computer data. What is the name of this? What is the name of the C2 server where the stage 2 binary tries to upload files? If you enjoy the task, yeah, we've already done that long ago, I think. But let's just open it to make sure. So yes, it's done. So, let's start with opening here, because let's imagine we don't know what kind of executable it is. Now we already know, but imagine we don't, right? We have this where-will-app we don't know anything about, so we see that it's an executable file, 64 bits. GUI, this one. So it is not this other one. And what else can we see? Actually, let's load it this at the same time because it's slow, right? So, of course, we already have it running. Well, let's just open desktop Verilab, and this is still going. P plus Windows Server 2008. We can also see here 45A and so on. First text bytes. And it was called PD. These are it still says wait and lots of stuff, right? What's my computer doing? AMD 64 again. Resources. Yeah, right. What else did we have in here? So maybe it's just that old manifest. Yeah, let's see if it gets more time, you know, it might find something more. So where will have DLL? We're looking for function names. So form one. Fancy app. We have forms. Can we like see the form? I'm curious. Or is it the code? Which it actually is code, of course. So let's look at this. Enable visual styles, set compatible text render in default, run form 1. So we have to form 1. Initialize component. Test all the components. I don't like remember even how to. Maybe I should read from the top, not the bottom. I don't know where the bottom feels like nicer. Timer take. Timer stop, hide, download, and execute file. That's probably the answer because What's a function if it downloads and execute files? Okay. Will it accept my parentheses? Yeah, but it removed them. I was thinking you probably don't want those. Once you execute the where will .exe, downloads another binary. We haven't run it yet. The download domain name is one. Yeah. So whatever. Let's continue looking at it. So download. Can I click this? Yeah, it shows us this, which is not a long hop. And then we have address. Domain name from. So I think it wants this mayor C2. Do you think we can paste? Yeah, we could. So I don't think we can get any more information from this, but let's look at it anyway. So path combine the Explorer.exe web client if exists. Text, and text is Explorer.exe. What a variable name. Download file. So it deletes the file if it already exists. That's what it does. Then it downloads it to the same name. Okay. So Explorer.exe. So this is the answer to the other question, by the way. So there were more answers. So we could have seen it happen too, of course, but it's more fun to read from the code, right? The stage 2 binary is executed automatically. So I was like, yeah, Explorer.exe. Well, that's a stealthy name, right? If that's running, if that's not running on the computer, web client download file, process start. So it starts it too, with a nice name of text. But I'm too annoyed at such a tiny thing. That variable naming. Possibly on purpose. I don't know. I think it will get, it got the. This is .NET, so I think it's actually exactly what this was. Timer start. If it isn't Windows, otherwise start with the interval of 3 seconds. That's quite often. So oopsie. Why did I write? Load. Here's initialize component. Oh, is Windows is also a function. Well, that's where we found that one. So we will like check the full form one. So I'm a bit curious what login form is though. Download and execute file. Login form, new login form. Variable login form show. So they're like showing us something, so we think it's a real program kind of thing. But we don't have the password, so we can't do anything. That's tricky. So let's minimize it in case we were to need it again. And we're supposed to run it. As it told us where the file will appear, right? Let's just open the downloads directory and run the program. So, or we could just have downloaded the URL. I mean, if we had the internet. So now we have Explorer here and we get the login. And it's running Explorer exe. So not very pretty to show that, right? So we kind of know some things already about Explorer exe. It's not a GUI like this. I should have waited 3 seconds. So, well, let's open this one too. Here. So now we're going to downloads and Explorer exe. Right, I know I had it up before. We can see console.net, my application app, Explorer exe. What is the name of the C2 server where stage 2 binaries try to upload file? It is this. Details, I guess. Let's see how much of this we got now. So, create a zip file. Let's look at the code. I'm assuming we could find a new zip file somewhere on the machine because it should be started and run and got some data, and we should probably see the zip file name here too. Yeah, that's a bit of a challenge, right? Is it in here? Well, that's just random. Strings. There's probably something .zip here, right? Of course we're going to look at executable anyway. It'll probably be a .zip here. Collected files.zip. So right click, value. So And that one is I've already done, so let's look at the executable anyway. I did click minimize. There. So it is in downloads. It is just a bit slow. I think I'm glad I didn't do this on Christmas Eve, because I think a lot of people were doing it then. Which is a bit of a crazy thing, right? But I think so. So, there's the program. Let's just click program 2. And we should see the class and all the functions. So we can see all the code nicely. Let's look at the tiny ones first. Log is just console write line. Private static void upload file to server. String, here we can see the C2 server. Web client upload file. Zip file file uploaded correctly. And I'm looking for the variable name. So it was in the arguments, I'm sure, yeah. So zip file path is an argument, and here it's called text2. So let's just open main, so we don't have to scroll so much. So we have source, and file types. String, folder path, my pictures. Okay, searching for files in folder path. Text path combine, collected files, create directory. So it's creating a directory. It's getting files. Get directory.get files. Okay, so it's just listing them. Then it copies all the files. It doesn't just zip the directory. It makes a new directory. Because it just wants these types. Okay. So, very secret files. String, text2, path combine. Collected files was set. Here we have it was that file, yeah. Not surprised, right? No files were found matching. Extensions. Files found in copies, exiting zip file in the temp folder deleted. So, file exists text2, file deleted text2. Creating zip file.create from directory. So there's a using up here. Come on. So let's see. System iron compression. So I guess it's in compression there. Oh, it's so slow. Where were I? Combine. Exists. Copy. Create from directory. Zip file, create from directory. That's where I was. Okay, then we know that. and then it deletes the zip file too. Existing zip file and pictures deleted. Zip file copied to pictures. Uploading zip file. Upload file to server. Directory delete. Okay, so we can just close this thing down. Let's just make sure I didn't miss any questions before. Yeah, so there.